Good. So let's start. Today I will talk about our JS SDK and our Polygon ID ecosystem. So let's start with a quick overview. So first of all, I'd like to say that this is not just a library. This is a software development kit for identities with zero-knowledge features. So what does it mean? It means that you can develop self-sovereign identity solution based on our framework, and at the same time, use unique zero-knowledge features and capabilities. Also, I'd like to emphasize that everything is built on top of IDENS3 core libraries. This is a set of protocol libraries development by IDENS3 team. So I will talk about them a bit later, and we will go through the documentation and everything. Library itself is written in TypeScript, so it's easily importable. We can use it in different environments, and it's easy to read with good documentation and build. And our JS SDK library is designed to be pluggable, so everyone is able to extend actually the most of the functionality from our native library by himself. So let's talk about the core libraries underneath. There's 5 of them. It's JS crypto library. This library is responsible for such crypto primitives as baby jab and Poseidon hashing. And the cool feature is that it's actually available in the browser. Another one is library of JSON demerkalization. This is a cool allows us to do really great things with JSON documents when we can transform them to the Merkle trees and receive a root, and then work with them for further steps. Everything is dependent on the core, so we have a possibility to work with ID and claims, and then we can work with them in the circuits, so specific zero-knowledge programs. Without that, it will be not possible. Library JSON-WZ is a new standard in the crypto world that we defined. So it's like standard GVT or GWS tokens, but with the possibility to share the zero-knowledge proof instead of just signature. And the last but not least is library regarding work with Merkle trees. With this library, we can work with sparse Merkle trees and build our issuer software on top of it. So this is a link to the documentation. I will share the presentation later, so it will be available. It's not. It's important just to understand the core concept when you work with our Polygon ID SDK library. So let's move further. What are the main features of JS SDK? First of all is the key technology, because we enable for users to generate gross 16 zero-knowledge proofs. In the future, we are going to support different proof system, potentially including Plonk system and Plonk zero-knowledge algorithm. Our library is extendable, so you can write any custom plugins for storages, wallets, or proof generators. Our library was always and will be, I hope, W3C oriented. So it means that we, on each level of our SDK, we work with decentralized identifiers and verifiable credentials. So as for now, we support Polygon ID and IDENS3 DID methods, but in the future release that will come really soon, we will allow third-party DID methods to generate zero-knowledge proofs in our system. Also, one of the uniqueness of our JS SDK is multi-purpose, because it's used for everyone. It's used for issuers, verifier, and holders. And the last is that we're environment friendly because it's possible to run our JS SDK in different environments like Node.js, Angular, React Native, and browser, which is pretty cool. Also, I'd like to take a note that as Polygon ID SDK was designed to use all benefits of zero-knowledge technology, users can still work with credentials and identities in the common way, create them, sign, and use other W3C standard features. So what are the main benefits? First of all, our library allows to build an identity wallet based on identity core protocol. So you can create an SSI wallet for your solution and or use existing Polygon ID DND methods in your applications, and it will be easy to do. Second one, you can build your own issuer software and have an ability to publish state and use Merkle trees. So not a lot of issuers today use Merkle trees as a storage for their credentials, and we allow this possibility. And final one is that we allow to build verifiers to work with JWZ standards, so zero-knowledge proofs and messaging protocols. We'll talk about that later. So actually, what's inside of our SDK? To group everything for all parties, like verifier, holder, and issuer, we decided to split our core architecture of library to several main parts. This is identity wallet, credential wallet, protocol part, key management, and proof generation. So let's talk about each of them in a bit details. We will not go too deeply, but at least we can cover something. So identity wallet. When you will work with identity wallet, you will receive a possibility, of course, of identity. But it's not only an identity creation, it's also generation of each crypto primitives, for example, like Merkle trees of identities, its genesis state, and also maybe job key. And as a result, you will have a DID, a valid DID identifier, and our baby job credential that in the future can be used for signing, publishing, and everything. Also, in the identity wallet, it's possible to issue credentials. So if your identity acts as an issuer, you will have a possibility to issue credential. By default, all credentials are issued with only one proof, baby job signature proof. But of course, it makes sense later to include the credential to the Merkle tree of issuer and publish state on chain. This will give a possibility to create identity sparse Merkle tree proof. So it will mean that, okay, now our credential is anchored to some, and it will be possible to authenticate with such proofs. When we talk about publishing states, we also meant the possibility to publish to the reverse hash service. I will stop on this more detailed later, but it's a cool service that allows us to provide an ability for anti-track for identities when they build the non-revocation proof of their credential. Another ability of wallet is to sign data and, as I said, create proofs. We can sign with baby job key and Ethereum keys. And yeah, last but not least, it's working with Merkle trees. We're allowed to work with claims tree and revocation tree for now. It's possible to generate a proof of inclusion to the claims tree or non-inclusion, and the same for revocation tree. For credential wallet, it's basic stuff regarding the CRUD operation and credential status check. So each credential, according to W3 standard, has a field credential status, according to which we must be able to verify if credential is actual, if credential is not revoked, or everything. So we do have support of several types. One of them is strict non-revocation proof from the revocation tree, and another one is reverse identity sparse Merkle tree proof that allow us to build the revocation tree of issuer in the reverse flow, so it's possible to not to show the revocation of credential to end users. Yeah, and as I said, this wallet supports reverse hash service. Regarding the protocol part, If you know the DID-COM protocol, we followed that specification and created a set of our protocols to handle the authorization flow and, for example, credential issuance. So we introduced the implementation of JSON WZ Packer. I will show you an example how it will work and what is JWZ token in our case, if you don't know. And among with that, we also do support for JWS Packer with Ethereum signatures for now. But in future, we are going to support more crypto algorithms, of course. And this part contains all protocol messages definition. So as you can see here, it's a set of credential messages of credential protocol. And mostly it's concentrated in credential issuance, authorizations, and request of zero-knowledge proofs. Also, there are some defined message to check revocation status or request one. We are working on the documentation, soon it will be published, so you can go through it and understand it more deeply. One of the crucial parts is proof generation. So as I said, on the crypto level, we support two types of elliptic curves. It's baby jab curve and Ethereum curve, listed on the screen. For the proof generation, we support the gross-extend algorithm, and we use Snark.js library for that. For the circuits, so these programs that help us to actually generate a zero-knowledge proof, we support several of them. For the authorization, we use AuthV2. For proof of the credential data, we use our atomic circuits, both for signature and MTP proofs. To publish state to the blockchain, we need a state transition circuit support, so of course it's supported. And in the future, we are going to support also preparation inputs for atomic on-chain circuit. So it will be possible with our SDK to prepare inputs for on-chain zero-knowledge proof verification. And yep, as one of the features, we also support a selective disclosure, so it's possible to disclose the data if it's wanted to by verifier. And the last part is storages. So we tried to make the library universal. So we defined the interface side data source that can be redefined or implemented by you. And actually, you can have any storage that you want. So when in the SDK itself, from this box, we do support index.db in the browser and browser local storage and the memory as example. But you're free to implement your own storage, so you can increase the security of the data or the storage capabilities. So let's go to the part how to use it. If we have any questions, I will answer them after the presentation, so no worries. So how to use our library? If you're using npm, just npm install, just latest version, and you're free to go. If you work in the browser and do not use any framework, it's also possible to use. You just need to import the UMD build from our scripts. So that's how it is. The most questions when people start to use our library is go to how to create identities, how to issue credentials. And actually, we do have a quite polished tutorial regarding that. So I will not step in on each point right now, but I think we can have a quick live coding session regarding that. So I will show you how to create identity. But you always can refer to the tutorial. Let's just show this function. I will describe everything on the top level. So, okay, you need to create identity. What parts do you need? You need a storage, you need a key management system, and wallets. So what are the storages in our system? Storages, there are several of them. It's a credential storage. So the business entity that is responsible to store verifiable credential, and actually it can use any data source that you provide. Here in the example, all the examples are in memory, so of course it's not recommended to use in production or any test environment, so just for the local development it's quite useful. So you need to declare the storage, you need a credential storage, you need an identity storage for both profiles and identities. You need to declare Merkle tree storage. So this is an entity that will have all the operation regarding your Merkle trees, how to add leaves, how to read from the tree, how to generate the proofs, and everything. This parameter is the depth of the tree. By default, it's 40. And also, the crucial parameter is states. So state storage, when this source of truth, when we can check the state of the issuer, state of the user during the verification process. So it can be any EVM compatible state storage. Right now, it's our contract address in the Polygon main network or test Mumbai. So to init it, you just need to use default config, use your contract address and RPC URL, and you're free to go. Another important part is key management system. So this is just an example how to init it. You just create an instance of key management store, and then you need to register different key providers. Right now, we support Ethereum keys and Baby Jump jobs. Here in this example, we do register only Baby Jump job key. Yep, and that's it. So when you have this initialized, you just need to call create identity and pass there the parameters. So if you pass everything, it will be a Polygon ID identity created. If you pass something explicitly, you can modify the method, the blockchain network ID for the ID method. And also, it's important to use revocation options. There was a lot of confusion why we should include this. So we decided to make it like an explicit way as a mandatory option. So when you generate identity, as I said, you don't only create an identifier, you also create a credential that will be responsible for signing and everything. So let's imagine that you are an issuer, you created this credential, and then when I want to generate a proof that I have a signature from you, I need to verify that your credential is not revoked. And here we go. We need to check it. So these parameters are responsible for the next, how the validity of your credential will be checked. You are able to provide several options there. In this example, it's provided reverse sparse Merkle tree proof type and reverse hash URL of the service. So it will mean that it's possible to use in the browser. So if you create an identity in the browser, you still have an ability to fetch the revocation status. Of course, if you work on the node server and want to develop a node, you just need to, or you can include not this type, but a regular one that with a regular endpoint that will return the validity of your credential for issuer. And yeah, actually that's it. So here I listed some examples what you can build with our SDK. And yeah, probably I can show you some of them. We have a pretty good tutorial of browser wallet. So if you haven't tried it, I recommend it. It's pretty good. The extension itself, it's not, of course, production ready or anything, but it's good place just to try the integration. So maybe I can show you quickly how it can be done. So you just go to extensions, you download our repository, and you can load unpacked extension here. After you installing it, you just can create an identity with some password. I will use simply one. So, and you already have an identifier and credentials that I was talking about. Now we go to the issuer. So we want to receive a credential for it. And when we sign up, the extension will be opened. And when I press button approve, behind the scene, it will be zero knowledge proof generated. So my identity will be authorized to this website, and it's happening right in my browser. So we can see that it's from identifier X5. And if I open my extension, I will see exactly the same QQF, and it's coming from it. And actually, this is a JSON Web Zero Knowledge token that I was talking about. It's our representation of GVS format. If we open our tool Polygon ID, we can JSON Web Zero Knowledge Explorer. We can validate it, and we can see what it's inside. And inside of this proof actually is a protocol message for authorization sent by specific identities that we generated. And of course, message have specific headers that say, okay, we used a specific version of circuit to prove the integrity of the message. And here we have information that zero knowledge proof related to this identity is valid. When we did that, we are free to create a credential actually. So we can choose a credential and issue for our identity. And then if we press button fetch credential, so the procedure of fetching credential from the issuer endpoint will be started, and if authorized procedure, but in the end I will receive a KYC credential on my extension. Then we can go to the verifier itself and log in with request a proof that my identity has KYC credentials, and for example, the age is older than the specific date. And again, when I will open, extension is opened, and specific circuit is used. And if we press continue, the zero knowledge proof will be generated. So it takes several seconds to process, but as a final result, we see that we share the proof of the field birthday of the specific credential type. Yep, my membership has been verified. And also, again, we have this huge token that contains all necessary information to validate the data that is shared. If we brand it here, yep, it's verified. And you can see the difference. When I used a simple auth flow and the issuer didn't request anything from me, I didn't include any embedded proofs to the scope of the authorization response. But now we have the proof inside. So we've proven that we have a birthday field that satisfies the verifier's query. And here you can find a lot of metadata about the issuer, about the proof, and make sure that the token is valid itself. So this is how our extension works. And this is just an example what the JS SDK can do. So we created an identity, we imported the credential from issuer that doesn't use our SDK. And now we are importing to login. What another examples? We are really grateful to the Reader project that did some implementation of storages. So it's the implementation of our storages interfaces. And if you go there, you can see how it's easy to override or define your own, for example, key system when you can encrypt something additionally or use some custom storage. So it's not a lot to override, actually. Another thing that you can do is, of course, to follow our tutorials. And all the links are doubled here, so you can input them in the browser and watch it anytime. So, and the last, what I want to show is that we currently working on the MetaMask snap. So this now is closed repository, but we will open it very soon. And this is a possibility for you to use Polygon JS SDK inside MetaMask Snap. So you can extend the functionality of the MetaMask Snap with actually identity code and zero knowledge proofs. And I think that is just mind-blowing for now. Yep. So what I also want to show you, if we have time, please correct me if we don't, to do a short session how it can be easily installed. Let's have just 5 minutes. I will not show you everything, but let's go just through a quick example. So I have prepared a simple solution that imports a Polygon JS SDK, the latest version of it. And okay, my goal is to create an identity, as I said. So we just need to create a storage for identity. And this storage will be our interface, data storage actually. Now let's talk in this way. And as I said, we need several storages. So it's a credential storage. We provide a memory data source for it for verifiable credentials. It will store verifiable credentials. We need to provide storage for identity. And here we need to provide several data sources. One is for our actual identity entity, and another one is for profiles. I didn't mention profiles when I talk about JS SDK, but profiles, these are the things that can allow to increase the anonymity of your identity. So you can log into the different verifiers and use different profiles, use different identifiers, even when you have a single identity. So the next storage is a Merkle tree storage. It's let's just declare it here. And the last one is states. So we need to any EVM compatible storage. We can do it with default configuration that is coming directly from the SDK. But of course, for us, it's better to override, for example, to Polygon, polystates, and we will just redefine some fields. So we will use our contract address of our current state contract in the Mumbai and RPC URL. So after this storage is created, so we are free to go. But also one more thing is that we need a key management store. So let's quickly create one. We just create a commerce instance. We create a key provider, and right now it will be maybe job provider. So let's just create it. We need to pass key type, and we need to pass a key store. Right now, I will use in memory, but please do not use it in production. Yep. So the last step is just to register this provider for the keys in our MS service. It also requires key type. So that's it. Let's create a wallet. We need to create a credential wallet and pass there our storage and create an identity wallet and pass there our KMS and storage and credential. So now to generate an identity, we need just to call one function. So we need to call asynchronous function create identity and pass options there. So as I said, we can pass different options. If we pass, let's pass method Polygon ID. Let's create Polygon ID identity. It will be hosted in the blockchain. And it will be hosted in the Mumbai network. Yep. And the last parameter is revocation options that we actually need. The type will be reverse hash, and the base URL will be reverse hash URL. Yep. So if we just call this function, we can print the credential and the identity. If we just run one command npm start, oops, as always, 1 second. So yeah, it's just a duplication. Yep. So identity is created and house credential is created. So simple as that. And to create an issuer identity, you don't need anything more. You just create a new identity, and it will be your issuer ID. And probably we don't need to issue a baby job credential right now. So if we just go here, we have a credential, issuer identity. So to issue credential, I will use my nodes, and to create a credential, you need a credential request. So we create a credential for the specific schema, and to issue it, you just need to call an identity wallet, call the function issue credential, pass identity to the issue, in our case, it issuer, and pass the credential request. Credential request contains a schema upon which the credential will be issued, type, and credential subject data. And of course, information about revocation. So let's just log the result. Or yeah, we can save credential. Let's call it cred1. And we can call credential wallet to actually save it in the storage. If we will just log our credential and press npm start, we will receive the credential. So here you see that we have user identity, we have issuer identity, and now we have issued credentials. It is verifiable credential specific type. It has some credential data inside it. And also it contains a baby job signature proof that is signature of the core claim representation of the Merkleized credential. As a next step, we can request signature proof from from user actually. So I will not spend too much time because I guess we're out of limits right now. But if we have a valid proof request is always request to some specific field and the context of the schema, then our user is able to locate the credentials and generate the proof. So, yep, I duplicated it. Sorry. So, yeah, I need proof service and credential wallet to generate, and also, of course, I need to upload the circuits. I prepared some circuits to generate the proof. So I can find the credential by query in the wallet and generate a zero-knowledge proof of the signature, a page of the signature proof, just like that. So yeah, this part is quite quick, but it's possible to achieve in a few lines of code, actually. So this is a credential, and this is a zero-knowledge proof that we actually prove in some field. I will share this example also, but everything is available on the links that I shared before. So, guys, let's make something together. Contribution is welcome, and we always looking for the improvement of our code. So, thank you, everyone, and I will stop the screen sharing. So, if you have any questions, just write to me.
So, a little bit about me. I'm Emanuele Bruni, and I'm a mobile developer at Polygon ID. I have 8 years of mobile development experience, and I'm a Polygoner since August 2022. So, my passion for technology start since the release of Windows 95, but let me say literally exploded with the release of the very first Android device. In fact, my first Android device was the HTC Magic. I don't know if anyone know about it. But what I love the most about mobile development is to be able to reach as many people as possible around the world, sharing what we are doing and also the code. I'm a third paddle player in the free time, and I love traveling, and I also love especially Japan, and I visited Japan 4 times. But stop talking about me. And okay, next. What we are talking about is the mobile wallet SDK, and we are focused on the identity holders side. We will take a tour of the Polygon ID SDK, and we will look at the methods of the SDK, and also in the second part, we will go through a live coding session. So our wallet SDK is divided in 4 main parts, and one is the identity and credential, identicom, and proof. As you can see, it's quite similar to the JS SDK, but as I said previously, we are focused most on identity holder side. So we are interacting with issuers and verifier, but with a special focus on wallet. So Polygon SDK is the software development kit, and The identity wallet helps integrator create identities, store their credentials, and issue credential claim from issuers and generate proof requested by verifiers. Let's focus on identity. Okay, what is identity? Identity is a key functionalities provided by the SDK. Allows user to create and store multiple identities. Identity wallet creates for identities for a user. User can have more than one identity, and also we can create for identity different profile to be able to, let me say, have a sort of incognito mode with the issuers and verifiers. Okay, the identity methods of the SDK are the following. Okay, we can check the validity of an identity, generate private keys, as I say, creating, restoring, and backing up identities, retrieving identities and details about, adding or removing profiles, and signing message. We will focus on add identity. That is a key feature of the identity section. And well, we provide to integrators the possibility to call add identity method, but the SDK inside has a lot of steps and quickly private key generation. The method takes a secret key that could be generated from encrypted mnemonic seed phrase. And after that, a wallet is created, and the private key is used to create a new wallet. We are using the baby jab for security. After that, the identity is created and stored using the private key. And in the code, we use a lot the identifier and the private key. So what we are doing for every methods of the SDK is using always these two pairs. Okay, the credential part, the credential wallet lets user fetch credentials from the issuer and save the credential inside the wallet. Later, these credentials could be used to prove our identity on the verifier side. So once the credential have been fetched and stored, a user can later retrieve from the database, can update them, delete, and etc. This is the process to get the credential. Integrator scans the QR code displayed on the issuer side, and we get the identity message. So in the wallet side, we are going to use this identity message to authenticate and fetch the credential from the users. Okay, the issuers validate the identity and return a list of claim entities back to the integrator. After that, the credentials are stored on the SDK associated with the identity. Okay. Sorry. Okay. Inside the SDK, there are different credential methods. So we have the possibility to save the claims. So we store the claims associated with the identity. We get the claims, so retrieve when we need it, the list of the already stored claims. We also have the possibility to filter them. We can get the claims by IDs, and also remove claims by IDs, remove a single claim, and also the possibility to update. So let's go to the identicom. What is the identicom? It's the protocol that defines the set of rules and syntax of the data that needs to be communicated while interacting with an issuer and with the verifier. The protocol lays down the foundation for the semantics and the synchronization that is involved during this communication between the various parts. This is the same as we see previously. We saw previously with Vladislav. This is the main purpose of the identicom protocol. Inside the SDK, identicom part, let me say, identicom is the core of the SDK. So through identicom methods, we can get identity message. So we parse the JSON that we receive from an issuer or a verifier, and we transform this in an identity message entity. We can get the schemas, get the filters also from the identicom message, and also important, through the identicom, we can fetch and save claims. So we can scan a QR code containing this identicom message about a credential, and we can storage in our SDK this claim entity. Also, we have get claims from identity message, so we can retrieve the requested claims from our wallet, and the identicom is also responsible for generate the proof. Okay, one of the main feature of this section is the authentication. We authenticate in the issuer side and in the verifier side using the identicom protocol. We can get interactions. Interactions are the stories of our interaction with an issuer and a verifier. So in a second moment, if we remove a credential, we can retrieve this one through our history and this interaction. So we have also the method of add interaction, remove an interaction, and update the interactions. So as I said, a key feature of the identicom is the authentication. The authentication is divided in multiple steps. So the first one is checking if the message we have scanned is an out one, and we check if the current profile, and we get the current DID. After that, a proof is generated, and we get the credential that is needed to generate the proof. After that, authentication parameters are prepared, and also an authentication token that is the one that will be passed to the provider, issuer, and verifier through a URL callback. And then perform the authentication using the identity commons, so receive a response if everything is going well from the issuer or the verifier. The last part, the last section is the proof generation. The proof generation starts with the wallet scanning the QR code on the verified website. And this is the first step to initialize a proof generation. And this is the step that we are doing. So integrator select the type of credential for which is seeks verification. Verify website display a QR code depending on the credential type selected by the integrator. Integrator scan the QR code. By scanning, the wallet parses the query-based authentication request shown by the verifier. So before the wallet can generate a proof, it needs to authenticate itself first. So upon a successful authentication, the wallet starts the process of generating a signature proof or Merkle-Tree proof to be presented to the verifier. So after the proof is sent to the verifier, it analyzes the proof for its authenticity. That is the same that Vladislav showed previously. And so the verifier shows the authorization request and the proof information to the integrator. As the verification is complete, an integrator now will use the services of the verifier. This is the methods provided from our SDK. So we have a proof. This method is used to generate a proof for a given claim. It needs circuits. This part, we developed this part because we need to keep the application lighter. And so we download the circuits in a second moment. So it needs circuits downloading at InfoStream is the one that starts the process of the download. Also, we have a method to check if the circuits are already downloaded, and also a method to see the proof generation steps. Also cancel the download the circuits. Now I will go through a quick live coding session. I don't know if there is some questions. Okay. I will go through a live coding. Okay. The first step we need to do is to import the Polygon ID SDK. And also we implement a mobile scanner, a secure storage, where we are going to save our private key and our DID. So the first mandatory step to do is initialize the Polygon ID SDK. So I have already prepared the template to go faster. So we initialize our Polygon ID SDK by passing also the environment. Actually, we are using the Mumbai, the testnet, but we also support the mainnet. I also abilitate the logger so we can see what the SDK is doing while doing all the job related to authentication or proof generation. So as you can see in the mobile app, I click on initialize SDK, and the SDK is initialized. And also what we have to do in order to be able to use the Polygon ID SDK is download the circuits. As I show previously in the slides, we call the init circuits download and get info stream. And if you click in download circuits, we can see the circuits are downloaded. It's fast because I've already downloaded previously. After that, we can go to the identity section to be able to create our identity. So in identity part, when we click in the create identity, what we are going to do is to call the identity section of the SDK. And as you can see, for create an identity, we call add identity because we can create multiple identities and also multiple profiles for single identity. And so from the identity entity, we retrieve a private key and the DID that we are going to use for the next steps. So we save these variables inside our storage. Okay. If we click in create identity, as you can see, the identity is created. This is the our DID for the identity we have just created. So we can go to the next part, that is the authentication. And we are going to call the authentication methods from the SDK. Okay. As you can see, to be able to authenticate, we need the identity message that we are going to take from the issuer website by scanning this QR code. So using the get identity message to map the string received from the QR code to an identity message object. And let's retrieve the DID and the private key. Okay. So what we are going to do is click connect. Okay. Scan the QR code. As you can see, it's doing the authentication SDK. It's authenticating. Okay, perfect. So now we are authenticated in the issuer side, and we are going to do the next section, that is the credentials. So as you can see now, I don't have any credentials created in the issuer side, and we are going to fetch and save the credentials. As previously, we have to use the ID and the private key, and the identity message obtained by the issuer. So let's create a credential. Okay. Message. And also, let's create the method to get the credential from the SDK. We can. So credentials, scan QR code. We are fetching and saving the credentials. Okay. No, it's not showing the credentials. Okay, I forgot to. Okay. Okay. As you can see here, our fetched credentials, the KYCH credential and our birthday. So next step is to authenticate with a verifier. And we can go back to authentication, and let's create okay. We can connect, verify, and then the proof will be created. Right. Okay, let's try with this. Authenticating, it's creating the proof. Okay, as you can see, we are authenticated with success in the verifier side. And that's all. this is the simple and complete the complete journey of the Polygon ID SDK. And let me come back here. Okay. So guys, this is an open source SDK. Everyone is able to help us to grow and improve our SDK. And I would like to remind you that this is just the beginning of our journey. And let's keep in touch. If you want to connect with me, here are all my social. You can connect to Twitter or LinkedIn, or follow me on GitHub. And that's all.